In this video, we're going to take a look at significant figures. Now, before trying this example, we must first understand the rules that are used to help us determine the number of significant figures. So, all non-zero figures are considered significant. So, for example, 3.7 has no zero figures, so all values are considered significant. Here, there's two significant figures. Also, zeros at the beginning of a number are not significant. So for example, if I had 0.003011, all of those zeros preceding the number 3 are considered not significant. So here, the number of significant digits would be all the numbers after the preceding zeros. So there would be 4 here. Another rule is that the zeros within the number are significant. So for example, if I had the number 1007, the zeros within that number are considered significant. So here, the number of significant figures would be 4. And finally, zeros at the end of a number after a decimal point are to be considered significant as well. So for example, the number 4.30 times, say, 10 to the power 7 would have exactly 3 significant figures. Now the other rule is that for a whole number without decimal, zeros at the end of the number may or may not be significant. So for example, if I had the number 378,000, well, this number could have 3, 4, 5, or 6 significant figures. But scientific notation can be used to make the number of significant figures more clear. For example, if I had 3.78 times 10 to the power 5, then it's very clear here that the number of significant figures is 3. However, if I had, say, 3.780 times 10 to the power 5, which is the same number, here the number of significant figures would be 4. So if we just write the number in scientific notation, then it becomes clear as to how many significant figures there might be. Now the rules for adding, subtracting, multiplying, and dividing numbers of significant figures is this. When adding or subtracting two numbers, the final answer should have the same number of decimal places as the number in the question with the least amount of decimal places. Now same goes for multiplying or dividing. If you're trying to multiply or divide two numbers, then the final answer has to have the same number of significant figures as the number in the question with the least amount of significant figures. So let's take a look at this example. I want you to pause the video now and try this example on your own, keeping in mind how many significant figures your final answer should have. Okay, so when dividing 8.798 by 9.7, you will get 0.91 because keep in mind that this first number has a total of 4 significant figures, whereas the second number has a total of 2 significant figures. So the final answer has to have the same number of significant figures as the number in the question with the least amount of significant figures, where in this question it would be 2 significant figures. So my final answer here is 0.91. Now this answer, 0.91, was actually rounded up because the actual answer was 0.907. Now we have to round this number up because this has 3 significant figures and our final answer has to have 2 significant figures. And keeping in mind that the number to the right of the last significant figure is 7, which is greater than 5, which is why we round up to 0.91.